In example number 7, we're going to solve the system of linear equations using matrices. So here's our systems of equations. So we're first going to write the augmented matrix. So we have 1, 2, and 3, -1, 3, -2, 1, -1, -9, 8, -2, and then 9. So we notice that there's a 1 in the upper left-hand corner, so we're good there. And so we want to make the number below that 1 is 0, which is +2. So we're going to multiply that first row by the opposite of +2, which is -2, and then add it to row 2. So -2 times 1 is -2 plus 2 is 0. -2 times -1 is +2 plus 3 is 5. -2 times 1 is -2 plus -1 is -3. -2 times 8 is -16 plus -2 is -18. Next, now that we have a 0 there, we want to make this now 3 a 0. In order to do that, we're going to use the 1 in the upper left-hand corner and multiply it by its opposite. And the opposite of 3 is -3. So we're going to take -3 and multiply it by row 1 and add it to row 3. So -3 times 1 is -3 plus 3 is 0. -3 times -1 is +3 minus 2 is 1. -3 times 1 is -3 plus -9 is -12. And -3 times 8 is -24 plus 9 gives you -15. So now that we have a 1 and a 0 and 0 here, our next goal is to make this one a 1. Well, since the 1 here in the third row is what we want, then rather than trying to manipulate this 5, we can then interchange these rows. And so the easiest way to obtain 1 in row 2 of column 1 is to interchange row 2 and row 3. And this is how you write that. You're interchanging row 2 and row 3. So now row 3 becomes row 2, which is 0, 1, -12, -15. And row 3 now becomes 0, 5, -3, -18. So now we have 1, 0, 0. We have a 1 here, and we want to make this a 0. So we need to multiply this 1 by the opposite of 5, which is -5, and then add it to row 3. So -5 times row 2. -5 times 0 is 0, plus 0 is 0. -5 times 1 is -5, plus 5 gives you 0. -5 times -12 is +60, and minus 3 gives you 57. -5 times -15 gives you 75, and 75 minus 18 is 57. So now what we have is we have a 1, a 1, a 0, and 0, and 0 in here, and we want to make this a +1. So in order to do that, we are going to multiply row 3 by 1 over 57. So 1 over 57 times 0 is 0. 1 over 57 times 0 is 0. 1 over 57 times 57 is 1. 1 over 57 times 57 is 1. So now we're going to now rewrite this system as it represents an equivalent system. So in our top row, we have a coefficient of 1, which is x. So it's 1x minus y plus z, which is equal to 8. The second row, we don't have an x term because it's 0, but we have a y term, which is 1, minus the coefficient of z, which is minus 12z, and that's equal to -15. And then our last row, we don't have an x, we don't have a y because it's 0, but we do have a z, and it's equal to 1. So what's nice is so far we know what z is, which is equal to 1. And then we're going to back substitute it into this equation here. So we're going to get y minus 12 times what z was, which is 1, which is equal to -15. Add 15 to both sides, and we get y is equal to -3. Now that we know what y and z is, we can plug that into equation 1 to find x. So we're going to take x, subtract -3 plus 1, which is equal to 8, which becomes x plus 4 is equal to 8. Subtract 4 to both sides, and we get 4. So by using that back substitution, we would obtain the solution, which is 4, -3, and 1.